Okay. Hello. Welcome. Today we are going to try and optimize our colliders a little bit. So one thing I noticed yesterday when I was streaming is that if I come down underground and go to where the box colliders are, these are colliders that the chunk is completely solid. So I just spawn a box collider. The issue is that these box colliders are half colliders, which means that turn itself into a kinematic. So since these are fixed, like a half colliders, the chunk is actually here. You can't see because when I hit escape to open. So the chunk's actually in the middle, I guess. Yeah. So it's 0, 0 is here of the chunk. And so the half collider is extending half below, half back, half, rather than starting the collider from the corner. And as I was pointing out yesterday, these are actually box colliders. And are therefore treated as solid, which means that if you somehow clip inside them, it knows that you've clipped inside them and pushes you out. Whereas these colliders, if I turn my where do we want to go? We want to go inside a chunk, big empty chunk. The issue is if it's a really big empty chunk, it won't have any it'll be a box collider. So if I re-enable my dynamic, I should just fall down. Okay, apparently I'm getting pushed around inside of a... Okay. If we can get down in here. So, I must be hitting boxes. They're too close to the solids. Anyway, so what ends up happening is, at the moment, because these are both boxes, I'm stuck in between them. Whereas these ones, if I go in them, like I can actually move around inside these meshes. There we go. Now we're inside it. Since it doesn't distinguish between inside and outside. So what I want to do is first off fix these box meshes so they're actually in the right position, which might be a bit difficult because what I might have to do is move the collider to being separate from the object, so that if it's a box collider, it can be moved accordingly. So that corner of the box is the corner of the object, like is at 0, 0, rather than what I currently do, which is it's at 0, 0. The other option is to move the chunk center, but that seems like a bad idea. Is to like what I could do is, since all these chunks are here, I could just move them up in a little bit, which will fix that. But that means I'll have to offset the mesh back down. And yeah, I'm not sure what way I'm gonna do. I might just. It really depends when it comes to Bevy, like how compute intensive like multiple entities are, is I guess the best way to describe it. So I mean, one thing to do is go here, go here, go. I'm pretty sure I can read information about the no, this is menus. Main. Spawn cube. We'll probably get rid of some of this stuff. Chunk test. Okay, add chunk meshes. So here we say if you return a collider, we insert the collider. So what we could do, right, is go okay. We want to go commands dot entity e dot despawn descendants. So the assumption is that even if you don't get a collider or a water, we'll just remove your children, because if I regenerate a chunk, we need to make sure that it's not going to spawn water where there's no longer water, which is currently what the problem is that. So then I did down here, I said despawn descendants, because I had that issue already, like water would spawn water. So why are we? Oh, okay, we say get entity if let some e. No, it should be let some entity equals, okay, and then we want to say else, probably a trace here, trace, chunk entity not in world. Right. Continue. I think it's continue. We don't want to return, do we? Yeah, we're in a loop, so tasks iter. For ID in done. Yeah, first thing we do is remove. Alright, so we can get to here and say, hey, the entity doesn't exist. This is about letting the world like generate slower than the player's moving or whatever, so that if you like leave the zone that the player's currently in while it's still generating chunks, it will just disregard those chunks. Really, I probably should say when a task is despawning, do it. Well, first off, is this a vector? It's a hash set of chunk ID. Yeah, okay, so task. So I can, in theory, cancel them, like remove, cancel. Yeah, okay, cool. So I can just cancel them, that's cool. I should probably do that because that would probably speed up a lot of things when you're moving around. Anyway, so we go to here and we go, okay, we have the entity and we return if the entity doesn't exist. Yeah, it's weird though because it says you're the only one watching. Well, now it says there's 2 people watching. I'm not sure because I get 2 metrics. One tells me concurrent viewers and the other one says concurrent viewers, but it's like a 1 minute behind. But I'm not sure. But I've had it literally say I've had -1 viewers, so I'm not sure how that worked. But also, I've had people that I know have like watched part of the stream because they'll comment on it later, but I've dropped down to like no viewers and back up to a viewer. So like unless they left and came back, I don't think it actually reports viewers properly. It's really weird. Like I've also had it like drop down from like I had like 9 concurrent viewers and it dropped down to like 2, and then a minute later it was like, yeah, never mind, that drop to 2 never happened. Like I had it in my graph that it shows. Because I'll just pop this over. It has this little graph down here that shows like the count at that specific point in time, and I've had a dip in it appear and then disappear like a few minutes later, like as if they recounted and decided that it never happened. So it's just odd. I'm not sure how YouTube does. I think it just acts conservatively. Or maybe if the window's not focused, it doesn't count it as a view or something. Anyway, so we're going to entity and we're going to do despawn descendants. Right, so this, well, one thing, this will probably just speed up the, right, you need to be mute. Yeah, I think Tom Scott does a great video called like, why are computers bad at counting or something? And it sort of talks about the fact that because of all the decentralized servers that need to communicate and you don't want to double count, they tend to take the conservative option of the two and then work out what the actual count is later when the actual view doesn't matter. So if I went back and looked at my analytics later, it would give a much more accurate count than the live one, because the live one needs to make sure that it doesn't double count people for like playing ads and stuff like that. They don't want to pay me more than they have to. Which is a little bit corporate greed, considering they're like they return billions of dollars in profit, but yet they're like, oh, but we're losing so much money. Or like, we can't pay people any more than we do. Anyway, so we get our water mesh and we say with children, and then we say here and we say assets to ID. And, yeah. Yeah, it's quite a common thing. Like it's like 90% of the lag in my game at the moment comes from that kind of concept of I have everything running on different threads and using read-write locks. The issue is that if something like wants a read lock and 90% of things need a 90% of things need a read lock, and like 10% need write locks, and for only a specific point in time. But because all the read locks have to drop their read lock for the write lock to be acquired, it'll either bind up on the write because everything else is doing lots of reading, or it'll get stuck on the write because all the reads will go to sleep while they wait for the write to finish. Because otherwise they bind things. I think it's called a deadlock, where they're waiting for something that will never actually come. So they have to drop all their attempts to read, and they sleep, which means that the write may finish and start another write because nothing was looking to read it. And it was, yeah. So I have a few points where like I really haven't designed the architecture well. I've just been tacking it together on stream. Like I've not planned any of this shit out before I start the streams. Anyway, so instead of spawning the collider like this, we want to say entity dot with children, like so. P and then we want to go like p dot spawn, and then we want to go collider. Oh, we need a spatial bundle, don't we? Spatial bundle default. For now, we'll just do the default one, because theoretically the spatial bundle will most of the time be at 0, 0. It's only in very specific cases. Yeah, I didn't have much experience outside of some C# before I found Rust. But Rust is just so amazing as like an engine. It's just so nice, so nice. Or not an engine. As a language, like Rust is everything I wanted from a programming language. Like it's strongly typed and it's fast. The compile times aren't that long. The crate system is so much better. Like I still don't know how to include like external packages into C#. So I was literally only ever using sorry about that. The neighbor came over to tell me about things happening tonight. So my instant reaction is always to mute the microphone because I have no idea what people are going to say, and I want to keep my identity secret. I've done a terrible job of it. Like there's plenty of places where it's leaked out, but like don't want someone shouting my name in the background. Yeah, so you're saying that hopping into Rust was a tough experience, but I think that's all programming, because from like everyone I've talked to that's had a problem with Rust, it's almost always because they've learnt so many bad techniques from other programming languages. Well, not like bad, but like I was saying, you had minimal experience with C++, which probably wouldn't have done too bad for you because C++ is just really sort of free. But JavaScript would be fucking hell. Like I know JavaScript because I learned C#, and C# and JavaScript not syntactically similar, but like if you ripped out the strong type system of C#, you've basically got JavaScript syntax. Like you can just say let and then specify what you want it to equal without needing to declare the type. Thanks for the. Here's a good point where I'm saying about how the number tracking's not accurate. It says there's 2 viewers, but there's 3 people talking in chat, so I don't trust that when it says there's only 1 viewer. Anyway, I've had this discussion with a lot of people. I didn't find Rust particularly hard to learn unless I was doing something wrong. Like when I was porting one of my C# projects, I wrote for my dad a dividing head calculator, which basically takes in a device he's got in the shed that you give it so many winds and it rotates by so many degrees. And so I wrote a calculator that basically you could say, hey, I want to rotate, I want like 16 divisions, and it would tell you what plates you need to load and like how many rotations of the handle and how many dots to move on the plate in order to get it. And some you have to move forward and some you have to move backwards. So it's a good first introduction to programming kind of thing for me, of like it had some complexity to it, but it was fairly straightforward, and I had a chart that I could refer to make sure my math was working correctly. Anyway, so I ported that back to into Rust, and literally the only time I had issues is because I was doing something wrong. Like I had a loop that was checking all the plates and doing something, and it was saying, hey, you're moving here, and then trying to access it, because I didn't put a break when I'd found the correct plate. And it was that kind of thing of like, the only times I have issues with Rust is I'm doing something wrong. Like I know there are situations where Rust borrow checker doesn't understand, and therefore it will tell you that it can't do it, even though in theory you could, but that's what unsafe's about. Like you shouldn't be doing things against the compiler unless you know what you're doing. Well, so that's my thing, because I went from C# to Rust, and C# has a garbage collector. Rust doesn't have a garbage collector. And literally I noticed no difference. Like maybe it's just because I wasn't programming at a high enough level to need the garbage collector to do anything, but because Rust does its magic, the only time I can actually find a perfect example, because I was fucking around with it today, I need to worry about any memory management is something like this. If I uncomment this in, it doesn't work, it's broken, that's why it's commented out. But what I'm trying to do here is check that all the neighbors are loaded before I generate a chunk, because at the moment, if a chunk, if you generate 1 chunk into the future, it works, but if you generate 2 chunks away, it may generate the chunk before it, and then therefore there'll be like a wall, even though you can't see that face, it'll generate that face, because the chunk wasn't loaded. But so what this is supposed to do is iterate through all the chunks. And what I need to do is drop the map, because if I hold the map, I hold the lock, and it means that new chunks can't be generated while I wait, and that's what the sleep's about. So I've got to drop the map before. But that's like the only time that I use memory management, is when I'm trying to do async shit and I need to drop something that's holding something else open, and then, you can do your work. And the other place is like file descriptors. Is like you need to remember to drop the file descriptor if you are waiting for some other thread to write to the file, because otherwise it can't write to the file. You're holding it open, or you're holding it like so it can't be written to, and then so you need to drop that and recover it. But outside of that, like the garbage collector in Rust is just built in. Like if this reference went out of scope, it would be dropped, which is what the garbage collector is about. It's about checking to see if it went out of scope. So Rust built the garbage collector into the compiler, and then at runtime basically just knows exactly when it can drop things. This does result in some compiler errors where it'll complain that you're using something, and it's like, well, it should have been dropped. So because you used it again, you're actually holding onto it longer than you're supposed to. But again, that's what this is about. It could have been dropped because all I do is sleep and break. But if I don't drop it, it holds it, because it never goes out of scope until after the break, and you can't break then sleep. I guess you could break here and put the sleep here. But again, that still holds the map. The map goes out of scope here. I'm getting really sidetracked. yeah, so what I'm trying to say is I didn't notice the garbage collector disappearing because I never relied on the garbage collector explicitly. It was always just this, hey, if I stopped using a variable, it would go out of scope and get garbage collected. Rust does that as well. It just explicitly drops it. Whereas I think C++, if you don't destroy it, it just stays. And that's where your memory leaks come from, is if you don't explicitly clean up a memory, it just, sits there floating with no way to reference it. And what we were doing, we were spawning a collider with a spatial bundle empty. So, in theory, this should make no difference except making the code like fractionally faster. The other thing I could do is also change the water to do the same thing as this. So what this is doing is it actually sets, it doesn't access the entity at all, it just sets the asset correct and will immediately drop it if it doesn't exist, which is hilarious, but okay, so this should make no difference, and then from here we can then look at the collider, work out the size of the collider, and put the collider in the correct spot. I hope. I don't know. I don't actually know how the colliders work in Rapier, like at that kind of level. Well, the fact that the colliders all still line up is good, and then if I fly underground, these ones will still be broken. Yep. Okay. Cool. So this has made literally no difference except that now I can go to the chunk, and they all have a child, and some have two. This one has a water in it. Okay. I might, just for the documentation sake of things, also this stuff should all be in world, not main, but anyway, we're going to say name new collider, like so, and we spawn you, and you are water. Right, so now I'll be able to tell the colliders apart as well. So each chunk is given a name, and then each collider is given a name. Or the collider child name, and the water child is named. There's also theoretically going to be a water collider, but I haven't got rid of that, and I'm probably not going to for quite a while. Mostly because I'm lazy. Anyway, so from here, what information can I extract from the collider? Like, as ball, as unscaled typed shape, okay. Cast ray? What do you mean cast ray? What does this take in? Between this... Okay, weird. Translation, rotation, ray origin, ray direction, max time of impact. Okay. I don't quite understand. That must be something it uses internally. What, polyline as polyline. Cast local ray. What's a local ray do? Computes the time of impact between this transform shape and a ray. Okay. The issue I'm looking at here is I'm raw. Shared shape. Okay. So is there anything else I can do just quickly? So project local point. Okay, so raw, and then we want to go... So make mute, no, is, okay, compute AABB, okay, interesting, with a given position. So I get all the same powers here, but I can... Okay, is. So what we want to do is we just want to explore the code here and go shared shape. Okay, and we want to go, hey, the shared shape has an arc reference to a dynamic shape. Okay, the dynamic shape, okay. So, what shapes are there though? That's the question. Shape for ball, shape for cuboid. So, what we're going to do is we're going to say is cuboid. And we go if is cuboid. Please write. We're going to log info is cuboid. I'm just trying to work out how I'm going to determine what chunks need to have their offset calculated. So qualify. Ooh. Is it a parry shape or is it rapier Surely rapier prelude cuboid is the same thing. Yeah, it's literally just an alias of the parry shape. So, anyway. And then we need to specify that this is ID. So this will tell me, every chunk that is a cuboid, and hopefully it won't be like chunks with high chunk positions. Well, I don't speak French, so I pronounce it rapier, as in like the sword that they have as their logo. That's a script, or that's a video. Get a rapier. So this is a rapier. Like, we'll just go. I think pronunciation. I'm sure Google will have a pronunciation. Rapier. Did I spell that right? I don't know. R-I-P-I-R. Yeah. Sword. No, I've written papier. Rapier. Sword. Pronunciation. Yeah, this isn't all of them.
Rapier.
Rapier. I like how they've stretched this video of saying one word out to an entire minute long.
Rapier.
Rapier. Yeah, so this many tabs is nothing, because first off, if I just like pop this back over, yeah, there's this tabs over here, and then on my other desktop, if I was to Windows tab, there's probably that many again, if not more, because that's my main desktop. So it's got like, these are only tabs related to YouTube videos. Yeah, 128 gigabytes of RAM. Lots of RAM. I also need a new computer because this one is starting to shit me off. Like, it's just got something wrong with it. It's like a factory rebuild, but I'm just going to give it to my mum because hers is my old computer. And it's 10 years old, and it's just starting to shit her off because it's just doing weird shit, like taking forever to open things. It's only got like 32 gigabytes of RAM. But yeah, so this one needs like a rebuild and like an actual make sure that it's factory erased out. I did turn my virus scanner off on this one because the virus scanner was using 100% of the memory. To be honest, 128 gigabytes isn't that expensive. So you, the only limitation is I had to buy an entirely new motherboard to put 120 gigabytes in because my old motherboard only supported 64 or 32. Because even though it's a 64-bit computer, that doesn't mean that the bus has 64 wires, so it can't actually address the entire range. 128 RAM. Okay, it is a bit expensive, but like $500 isn't that much. And it's 500 Australian, so that's only like what, like 300 American? Something like that. Maybe 400 American. Yeah, it's really annoying. I gave my old computer to my dad. The computer before that went to my mum. And I need a new computer, so I'm going to give this one to my mum when I'm done. Hopefully I'll be able to get a new computer soonish because I've got a job now. For a long time I didn't have a job, so Yeah, like 350. That was the sort of the cheaper option because that was 4 sticks at 32, which I think is what I've got. But you can also get like 2 sticks at 64, which I don't remember which is better. I think you want 3 sticks at 32 because it increases the bandwidth because you've actually got 4 separate chips that you can read write to at the same speed. Whereas if you only have 2 chips, you may have to read and write to 2 separate chips, which means your caching's worse, but your speed, the amount of memory that you can write at once is better. What was I got sidetracked. I do this every stream. I get like so sidetracked. Anyway, so when we were running and seeing like, hey, when you generate, you say is cube, and it's zeros. So the zeros being cubes is good because 0 means that they're basically at the bottom of the world and therefore they are the statistically most likely. And I'm not seeing like 5s. Whereas if I was seeing 5s, which are mostly the sky, I'd be thinking it's not working properly. Anyway, so we go back to main, we go here, we go, hey, yeah, you've detected that it is cuboid. And the only time it is cuboid, okay, so we go spatial bundle and we go, I want to say something like if is cuboid. Okay, so we want to do that. Else we want to do this. So if it is a cube, spawn is cuboid. Otherwise, spawn a spatial bundle. But the spatial bundle is going to have a transform from translation. We'll work that out in a second, and then default. Okay, so this is going to be a vec3 splat chunk size as f32 divided by 2. Okay, so basically I'm saying, hey, if I ever say that and give you a cuboid collider, that means that your entire chunk must be solid because it's the only time I ever return a cuboid collider. And then we offset the collider's position to be half a chunk up, half a chunk to the left, and half a chunk back. Or half a chunk forward. I'm not quite sure which way it's supposed to go. This will mean that the collider will then line up with the actual chunk's mesh rather than how it currently is, which is at set 0, 0. But if I don't give you a cuboid, if I give you a mesh, then that means that you need to stay at 0, 0 because the mesh is generated generated exactly the same way as the mesh, and therefore will line up with the mesh. All right, let's click play, wait for everything to load, and go, well, the main meshes didn't break, which is a good sign. We just need to fly up in the air like this and go over here and be like, shoo, shoo, shoo. We go rigid body, we need to go like, hey, make me kinematic. I should really just swap to the character controller that's built in. Anyway, we fly down here and we go, hey, look. That's a little interesting, isn't it? If I was to, we need to go this one, thank you. I need a full screen because I have no idea where the center of my screen is otherwise. Here. Why is that not working? Huh, I was too far away. There we go. All right, so you've just become a mesh. Why? Where is your collider? You little bastard. I also have no idea why this is happening. This has got to be something to do with how Bevy culls off-screen chunks. So because the origin's like here, because I'm not looking at the origin, the chunk actually disappears and isn't rendered. Which would be another reason. Here's what I was talking about before as well. So this chunk has obviously been drawn before the surrounding chunks were generated, which means that it draws its edges. Which is fine because you would never actually be able to see that from the surface. It's just extra compute. Like you can't see it. And by the time you dug to it, like if I dig down like 3 blocks, no, I want to place air. If I dig down to it, it will literally redraw itself, and now it's gone. Yes, that's actually what I'm going to be doing this video. So currently, someone mentioned it yesterday, they were like, oh, you should mesh them. They technically are. At the moment, they're using an algorithm. It's not greedy mesh, because greedy mesh is a different algorithm again. But I call it greedy meshing. Basically, it's, I guess maybe aggressively meshing would be the best name for it. So if I go inside this square, what it does is this square will check along its plane. So each face has a plane that it will check, just so that, because theoretically they could all go left or right, but I did it in a specific way. There is methods to the madness. Basically, the ones on the ground will move into the screen from this position. So if you were to walk into this mountain, technically there's still ground below the block. So even if you clipped in a little bit, you couldn't like clip in and fall down, because there's technically a block still below you. And then, like, you know, the side ones do the same, but they go down. So theoretically, if you were to draw all of them, they should like interlock in a way that you can't clip inside, even though you still can. But that's partly because the camera arbitrarily moves. That's why I'm going to move to a player controller and not just move the camera. It's just that the camera speeds too fast. It can clip through the wall before the physics engine decides that it's not allowed to. Anyway, so back to the algorithm. What it does is over here, you'll see this square will check to see if this square is solid. And if it is, it will continue its mesh. And it does this until it hits an air block. Like if this block was air, it would stop here. And then what this block does is it looks here and goes, hey, do you have air above you? If you've got air above you, then you will have drawn me. So it doesn't draw it. And then it goes, hey, you, are you solid? And it goes, oh yeah, you are. So it doesn't draw itself. It doesn't draw itself. And so they all go like, I think it needs to check. Oh no, it checks. This one checks to see if this is air. If this is air, like this block here, like the up one, it will go, oh, I need to draw the mesh because I am the end of the chain. And it draws chains. So I guess the chaining's more obvious on the surface. So if I come up here, this one here continues all the way underneath to like here, or wherever the edge of the chunk is. Right, so probably here. So this one draws from like here to here, and all these ones under here don't draw, even though they've got a collider, which means that if you were to theoretically clip through these blocks, these 3 blocks here, you would still have something to stand on because the collider goes underneath them. And then looking at these, it must go down, like this particular face goes down. This particular face would probably go backwards. No, it's still drawing a square, so it doesn't go backwards. This one must go, yeah. So this one goes backwards. So this one must go this way. So this face is going, hey, this is air, so it stops. This face is going, hey, I don't have air, so I'm not going to draw you. And this one goes, hey, even though this is solid, it's still, you can't really see it because of all the other colliders, but there will be a collider going this way until it hits the edge of a chunk or air. And so technically they're meshed. What I'm going to work on this episode is things like, I'll get it to quickly check an entire face, and if an entire face is solid, replace the entire face. Because I don't have a complicated enough algorithm, like I can't think of a complicated enough algorithm in order to mesh like the optimal, like I think greedy meshing, which is the idea that like it would expand from the corner until it couldn't, and then it would move up. And so I just want to iterate through all of the blocks. I don't want to have to like specifically work out what blocks I haven't done and which ones I have. As I said to the person who asked yesterday, if you have an algorithm that you want to implement, the code is open source on GitHub, so you can like implement it and make a pull request, and I'll be perfectly happy to implement it. I just don't know how to do it. What were we working on? We were coming down here and going like, yes, hello. These big squares, wherever they went, over here, are they lined up properly? They are not. Yeah, they need to go down a half? Down 1? Is that 1 block? If I remove you, and I remove you. Okay, no, it's like half a block. Yeah. Yeah. Okay, half a block. Yeah, there should be in the description of the stream a link to the GitHub if you want to go read through the code. But yeah, this is less Bevy. This is, I'll show you literally the only place you would need to look. We go here. We go chunk, and we go somewhere. Also, if you can work on this, this would be lovely. But now, I'm gonna gen collider. This is the only function you need to touch if you want to do it. Basically, you get access to the chunk, which has a list of every block in the chunk. Colliders, I want to keep independent. Colliders, for simplicity, a collider is only the chunk that you're currently in. Mesh generation checks adjacent chunks, so needs access to the world, and therefore doesn't asynchronize very well because it needs read-write locks. Yeah, anyway, so yeah, just have a read. It's you don't have to contribute anything. So a chunk has a chunk ID, which indicates like where it is in the world. You know, and that's basically just its world position divided by 16. Then you have its entity, optional entity, because if it's not yet spawned into the world, it won't have an entity. So the idea being that you can generate chunks just purely so that other chunks can reference them for their generation, but they may not actually spawn into the world. So technically there's like an invisible boundary of chunks around. And then the actual blocks themselves, which is the chunk's volume, which is its length times its width times its height. And so that's the number of chunks in the world. So that, and then your block types. So when we go to the collider here, the collider takes in self. So it literally just has access to every block. And what I do is I go, hey, vertexes, and just generate a map, like a mesh. And then we go is solid, and it iterates through every block going is solid, and then we count them. And if the count is equal to 0, the block is solid. Okay, so we check through for non-solid blocks. If there's any air or any water, the block is not solid. If the block is solid, we calculate the half length, which is the size of the chunk, and then we return the half length. We return a cube collider of the half length. So it's interesting that doesn't work, because that's exactly how I calculate half length. Anyway, so if it's solid, we return that big square. Otherwise, we iterate through x, y, z, and then we just build a mesh out of the x, y, z. And then if vertex is empty, we return none, because none means that it's an air block, like that there is no collider. Okay. Yeah. So basically, if you wanted to optimize it, what you would do is in here, I run some kind of algorithm. So we run through like X, Y, Z, and we go current block, and we get the current block. So this is the block at the current position. If the block is equal to air, we continue. Air or water. We don't generate a collision mesh with air or water. So continue. And then for direction, which is like up, down, left, right, so it's the 6 faces of a block, we check to see if the block in that direction is solid. So that means that if the block above you is water, or the block, if the block above you isn't water or air, because they're the only not solid blocks at the moment, don't bother rendering yourself. Like you can't be collided with if the block above you is air, isn't. Yeah. So you'll always be solid. Then you check indices. So, okay, then we insert the indices, which is just the 6 points needed to draw the triangle. So this is triangle 1, this is triangle 2, because each is a square face. And then we get the plane, which is the perpendicular direction to the movement of travel. So if we're moving up, we get the forward direction. If we're moving left, we get the I don't know, backwards direction, up direction, down direction, just a direction that's perpendicular to the axis of motion. We then say if the block behind you and up 1 in the direction you're moving, I'm not quite sure. It's all very complicated. So we get the block behind you, which is what reverse does. It just Oh, okay. So we work out your perpendicular direction and then we step back one in the perpendicular direction. So if the block behind you is solid, if the block behind you is solid and the block behind you is not, the block behind you and in the direction we're traveling is not solid, it's very complicated. We continue, which means that this is just to stop multiple blocks drawing on top of each other. This checks to see if the block behind you will cover you. If it will cover you, then you ignore it. You don't draw. So I guess it must check if you're air. If you're not air, you don't draw yourself anyway. If you are air and the block behind you is not solid, I don't know. It does something. It works. So I don't exactly remember how it works. Then we extend the indices by the indices, which is just we add the two triangles onto the indices map. We then say len, right? And then we calculate the length that this extension needs to go. So the next block is we get the block in the plane and we say if the block is solid, if the next block is solid, increase the length by 1. So this is saying on this face here, this block, we're starting here, and we go, if this block is solid, extend the length by 1. If this block is solid, extend the length again. So we keep doing that until we find air. So we keep going until the next block is not solid, basically. So if there's air or water, we stop. We then we insert the position. We extend the block base. It does some fancy stuff. And then we extend the correct plane, which required its own thing, if I remember correctly. Faces block with len. So if we have a faces block with len, in here we have how to offset each one. So if you're moving in the right direction, the negative half of the cube on that particular triangle needs to be extended, or I guess on that particular face. So those 2 points along the y plane need to move down. So if we draw our triangle, like, let's put it in a comment so that it's easier. This is very complicated code that I wrote once on stream that I'm surprised I remember as much about as I do, but anyway. All right. So we have our 4 corners of our triangle, and what this is saying is that this is this corner, and this is this corner. I guess technically, because these are half negative lengths, it's probably this corner and this corner. So these two are these bottom corners, and these two are these top corners. And we're saying, if I want you, len, here, so len, okay, what's some stuff. So when I'm saying, hey, it's too long, what I'm actually saying is add 2 more lines. And so it stretches the square downward. And yeah, I guess that just keeps happening until that's probably a better square. Yeah, so basically the negative len, extends these down. So if it's negative len 1, 2, 3, and it just keeps making that rectangle taller. I guess this would be the way to do it. Alt, no, Shift Alt, like that. So it just makes it taller without adding the extra points. Yeah, so it just extends that. So we'll work on that later once I've got this fixed, because that might actually explain it better. Okay, so what our issue is that the cube is gone 1 too far up, 1 too far to the left. Well, like a half. It's only like a half here. The question is the collider too big? So we need to go all the way over here and go, hello. You don't stick into this one, do you? Yeah, you're not even visible. And the issue is that I can't actually... Oh no, there... Okay, yeah, because you're half too far that way. So you need to move half down, half back, half to the... Okay. So, not quite sure why that's happening, because I would have thought that half collider would have been the perfect size, because it's literally just half the collider. Anyway. Chunk size divided by 2 minus 0.5. Don't divide by 2 minus 0.5. I'm just going to It shouldn't need these parentheses because order of operation, but I'm going to do that because I always feel worried that it's now going to divide by 1.5, not a half, and then minus 1.5. Anyway, sorry if I went into a way too overly complicated explanation of that, especially considering I'm going to go into way more detail in like 20 minutes when I get round to optimizing that section. Okay. Hey, like I've kind of fixed the issue in that I have to fly down in these crevices. Otherwise, because the block is... that's a directional light, not the camera. Fixed. Alright. There we go. Now the colliders are in the correct spot. And what I was trying to demonstrate is I can't fly into the bottom of this. No, apparently I can. Oh, because I've gone rigid. If we go dynamic. See, we immediately are fired out. Like, we cannot walk into this block. But if I want to walk between these two, because the mesh, and this is a mesh, we can walk through because it doesn't distinguish between inside and outside. But these, we can walk between them because we get stuck. But we can't walk into them because they are solid. They are distinctly solid. That is the outside. Now, maybe I've got these going the wrong direction and it does actually calculate the inside and outside of meshes as well. But I wouldn't imagine it does because otherwise you wouldn't be able to touch the bottom like that. But the fact that I can just walk through... meshes. Okay. Can I walk the other way? Yeah. So the fact I can just walk through these just means I'm just traveling too fast. And when as soon as I pass halfway, like if I just tap into it, it bounces me back. But as soon as I pass halfway, it pushes me into the other side rather than out. See? Like, it's pushing me out, but out doesn't have a direction in a mesh. Like, out is, if that makes sense. Anyway, we should be able to fix the majority of those meshes. So, let's, do the reasonable thing and be like, tiny comment. I'm just trying to find code that is relevant. I don't know why cargo lock's not like removed. Anyway, we'll do that. We're gonna say fixed cube bore. Okay, so that's our cube collider fixed. Which means we no longer have to worry about the cube collider not being correct. Now we're going to work on that mesh. Slight mesh optimization, because again, I'm not going to do like full greedy meshing, which is the idea that it'll consume as much of the mesh as it can, but we will do some mild optimization. The issue is I think I need to swap these two while loops because I need to be able to increment like... Oh, no, see, that's why I didn't do it. Is because I can only really do it on like the entire X plane. Okay, so we've already checked here if is solid. So what we should do is say let is X solid. Is X solid? I guess it's xz solid, and that's going to equal I'm going really quiet because I'm trying to visualize shit in my head and it doesn't help when I'm trying to constantly talk. So we want to go We want to run along the entire X plane and the entire Z plane. So for a specific Y level. See, that's what I'm saying. This is only going to work on the Y because so we need to go okay. We need to be like 0 dot dot chunk size dot map that's Z. And then we need to go here. We need to go okay. So here's our Z. And then we're going to go map that, and then 0 dot dot chunk size dot map. This is our X. Right. And then we say okay, so then we want to go self dot blocks. How do we do it? So that one we just iterated for each every block. So we go it's Y times chunk area plus Z times chunk size plus X. All right. Dot map. Dot it's not count, is it? Is it count? Okay, dot is underscore solid. Right, this needs to be converted to a U size as U size. Okay, so can I do things like fold? Fold every element into an accumulator by applying an operation returning the final result. So where G takes in, okay. So your initial value, okay, map. Well, can I say like, all right, we'll try and use this fancy shit later. So we want to iterate this and we want to, but we want to go, well, I guess iter and then dot filter. So we don't need the map. We want to say filter expected found. Okay, I got a semicolon. Okay, so we iterate through all the z values, that then each z value iterates through all the x values and filters out to any situation where that specific value is not solid. Is solid. And you then return the number of solid ones in each row and then you in each area. And if that is both 0, so if there are no... Wait. Is solid. Is XY solid? I'm just following the same logic as I've got above, which is to go through and check that every block is in solid. So if XZ is XZ solid. So if XZ is in fact solid, we want to return block face with len. That'll be why the collider didn't work, is we were actually using half squares, which means that it was half a square off. Because funnily enough, the center of the square is at 0, 0, not... Okay. So, theoretically, this is only down. So we go back to here and we go as hello. So we're going to push here and go vertices dot extend. Oh, that's on the other side of a comment, so that's not going to work. Okay, so half length. So we need to go find those parameters half length, which I'm pretty sure are just some constants. Like so. Constants there. Alright, so then we want to go, don't bother subtracting length. Okay. Right, so we do that, and then we do that, and we do... So what do you return? A array of... Okay. So it's like here. It's getting very complicated. Alright, so you don't do anything, you literally just... You just convert it into a different format. Okay. So, let's have a look. We have... Negative, negative, negative. Assuming the block goes in the positive direction, we would want half times chunk size as F32. I said F32. Basically, anywhere that we see positive numbers, we want to multiply by that, by that. So what I mean though is I have no idea how to extend this into the doing anything but a single face, because what we'll do now is we'll go continue. So we just don't check the X, the Z and X aspect if the Y is currently flat, which I feel like is also going to break because you then iterate direction, don't you? Yeah, iterate direction. So we don't even want to continue. We still need to iterate through, and we need to go if direction equals direction down and is xy solid, continue. This may actually add more. Because pretty sure this just ignores whether the entire bottom face is visible at all. Right, so what we'll do is we'll go in here, we're gonna go turn our camera rigid body to fixed. We fly down and we go well, it clearly didn't work how I expected it to work. So one reason this may not have worked is we've extended all of the positives. We probably only wanted to extend... Yeah, we don't want to extend all of the positives. We only want to extend the XZ, which, funnily enough, with the specific one we've selected, which is down, none of the Y's have anything to extend, which is really weird. Okay, we want to do things like info. I probably want to go... Where's our default chunk size? Mod. Our default render distance or view distance, or whatever it's called. Yeah, no. View distance. Okay, I want you, wherever I implement default, to be 1. Please only generate a singular chunk. This is still going to generate more than one chunk, but it should reduce the number of chunks down to like a more manageable number. Right, we want to go info is solid. Okay, then we want to go, what is this, like X? We want to go self.id entity, self.entity entity and Y. Alright, so when I run this, it should print out like 16, 17, oh god, a lot of times that it's solid because it's going to be like the ground up, if that makes sense. So when I click play, first up, you generate too many surrounding chunks. As soon as I move, it'll disappear. But anyway. Well, apparently it didn't print it anywhere, so... I don't quite get... I don't get it. It should have printed out a whole bunch of times. That it obviously won't print it out if the block's completely solid. Which means that this logic probably isn't working. Okay, then for chunk z in 0 dot dot chunk size if self dot blocks dot blocks y times chunk area plus z times chunk size plus x as use size dot is solid. Okay. True. Well, I guess this is a terrible way of doing this. It's so inefficient. We run a second loop entirely. But this should then print out if it's solid. I just need it to get to the point where it's printing out if it's solid so that I know that it's working. Okay, it printed out a lot of is solids. And funnily enough, they all do look more transparent. But maybe that was just because the meshes hadn't rendered. We want to go back to a... Well, the question then becomes, if I turn back on my dynamic while inside, do I fall through it? Yes. Which... It's definitely not doing what I'm expecting it to do. Which is somewhat interesting because... This is why I want it to be limited to a single chunk. God damn it. Alright, when we say chunks, gen start chunks. Lucky Jones settings. You don't ask for shit. I'm just gonna say 0, 0, 0, 0. Shouldn't be messing with this. Should make it like a constant or something. I just can't be bothered. Okay. God, I gotta stop hitting escape. It's E to open the menu. Escape will render the fucking 5 chunks because of how I've got it set up. Play E. Annoyingly, I can't hit escape. Or it will break everything. Alright, so not entirely sure what's going on. Like where is the whatchamacallit, there should be horizontal like meshes. Is that what these are? Because these don't have matching triangles. No, they're almost certainly from you coming back. What? Ah, I've hit escape. You weirdo. What I don't get is it should be generating. It could be. Right. It's probably that I'm generating them all at literally the same place. So you add plus line. Okay, so we need to offset it by like Y as well. I think. So when we say map U, we don't add X, but we do need to say that the Y is plus Y. Because they could all just be at the same layer then. So that might fix it. Is that how this one done here does it? Does it add Y? When I insert it, I add X, I add Y, I add Z. Okay, well first, I am getting very sick of my terrible implementation of shit. Okay. Fucking hit the camera. Set its the camera is rigid body is fixed. Play. Alright. Where are my Y planes? Like it should have a line through the middle of it because it Do you have it? I don't quite understand. I really need to disable the fact that that defaults to 5. What I also need to do is stop hitting escape. I might just fuck that off because I actually need to be able to get to that menu, and every time I hit escape, it fucking toggles the escape menu, so you can get fucked. Because you're doing my head in. I don't have to keep restarting the game every time I accidentally press escape. Considering it's basically muscle memory to hit escape at this point to free the mouse. Alright, anything that's not 0, 0 is going away. What's the bet the camera flew away? You. Body fixed. Ah. No, it said. Okay, that should bring the camera back. Anyway, so what the fuck? Okay, we don't want you. You. Okay. -1, -1. Get rid of all the negative ones. Final number is not a 0. We don't care. Okay. And you. 1, 2, 3, 4. Okay. So, that means this is a single chunk. Where there? Okay, so the very bottom one, well, the very top one apparently doesn't have anything. The very bottom one has a square collider, which means that we can get rid of you. And we also want to just go like, hello, yes. You, can we remove your collider? No, I don't think that's a thing you can do. Okay. Anyway. You would be the perfect candidate. So that must be that one. So despawn and despawn. Nope, you were not the perfect candidate. So anything without a -2. We have a -1. Anything without a -2. Oops. Then anything without a -2. Do you mind despawning for me? Alright, so well, apparently that chunk survived somehow. Probably because it ended up with background, or button group between it. Okay. So. Interesting. Why do you... Where is the big triangle? Like somewhere in this mesh. And that's why we need to get rid of the one at 0. Because the one at 0 is the big square. So where is your triangle? Somewhere there should be a triangle. Like going through the middle of this thing. What if I just said like collider? When we say chunk, we generate this and we go into here. Excuse me, can you just like minus, okay, we add y, but then like minus 256. I want it to be outside the square. The direct square that it's drawing needs to be outside of the square, because otherwise it's not going to work. Like I just need to see it. Like for all I know, it's just that it's plane is wrong. This is the thing that's throwing me off the most. Is I can't see it. Like, if that makes sense. Like, where? So it definitely spawned some, right? Like it said, yeah. Your 97 0 is solid. 80 0 is solid. Okay. Like I said, minus 256, and it's not down here. And it's not all the way up there. Well, I mean, maybe it is. So I don't know where the missing fucking collider is. Like, it should be drawing a square, like, unless I'm not implementing it properly. Do you know what I'm probably not doing? I'm probably not inserting the indices. So that would explain why it's not rendering. It's an array of arrays of U32 2 by 3. Okay. By 2. Alright, then we're just going to move this right to the top, because that's just a constant that is used for generating colliders. Alright. And then you are the same, so you're I and D. Okay. Yeah, that should hopefully work. So basically I'm expecting it to be really far down below. Alright. We need to go here, go kinematic, please. Hey, look, there's a bunch of triangles down there. Now, they don't seem like they're in the right spot because they should line up basically perfectly with the bottom of that. But the fact that they're down there at all is pretty nice. They're not the right size. Like in the slightest. But I mean, we can at least remove the minus 256 now. That was literally like so that I could do that. I'm gonna say do that, and let's have a look then. I don't understand. Oh, because it's half size, isn't it? It's because I'm multiplying. No, it should be plus. Hence, they're ending up half the size. I fired off. Alright. Rigid body fixed. Let's reset you to 0. 0 enter. 0 enter. 0 enter. And go. Yes, hello. Up here. So, inside here, you are drawing a plane at the bottom level here that covers to there. And then your one is the same, but it's like at every layer. Okay, so what that translates to is, yeah, it's definitely plus, not multiply. Because basically we're multiplying by a half, when in reality we want to be adding a half. Adding the width plus a half. Okay. Okay. And again, set you back. Fixed. Okay. So we come in here. So now you can see that it's drawing a... That doesn't seem quite right. But we'll work on that in a second. So... I think it's probably just drawing slightly too large of a triangle now. No, the triangle seems to be the right size. Maybe. No, the triangle's definitely the wrong size. So it's starting at the right spot. Maybe. Or not. It's really hard to tell. It's too many lines. Again, let's delete everything that doesn't have all... Like, let's say -1. So that's you... If we just kill all of these surrounding chunks. We don't want to kill too many, actually, because we need to be able to be like, which... So, yeah, they definitely seem to be extending half in that direction. And are they lined up correctly on this corner? That's the question. I'm going to say that's probably not. So they're... And is this the positive corner? That's the question. So there's -16, -16. That's where I'm standing. No, we want the transform of the good player. -10. Right, or 10. So this is 0, 0, 0. Which means that should be the origin point of this particular chunk. Right. Yeah, so they're going one too far that way, and not far enough that way. The question is which corner is this one? This is the negative. So they're not going far enough in the negative direction. Interesting. So negative. Right. Well, one thing to do is, again, when we're iterating through here, okay, first off, we can say, I need to check this. So, iterate through. They're also... So we check each block. And... y does not equal 0 and I think we can just do this. Get rid of these parentheses. And y doesn't equal 0. So if y is equal to 0, No. Why doesn't equal 0 and y minus 1? Maybe. What that should do is mean that only at the y equals 0 and at the or if the block below is also not solid, so if it didn't crash, that'd be good. I need to turn my rigid body back. Fixed. Okay. So it's definitely drawn the bottom, like so. And then when I fly up into it, it hasn't drawn... No, it's drawn all the other layers too. Which means that... Maybe I need to check that as a whole. So it's... The block isn't solid. And y doesn't equal 0 and the block is not solid. Not solid? Maybe that'll work. And y does not equal 0. No, I'm pretty sure I'm saying it's not solid. Okay. Set it to false if the block's not solid. Or y does not equal 0 and the block below is solid. And the block below isn't solid. Really getting my Boolean math mixed up here. What I want to do is basically say, if you're on the bottom layer, and the whole thing's solid, draw it. If you're on the bottom layer, if you're not on the bottom layer, and there's a hole below, draw it. Just so that it doesn't draw like every layer inside a chunk that literally has like one spot of air. I just want it to draw just the bottom. Okay, that took a really long time to load. Bridge body fixed. Nope, it's still doing it. God damn it. It's all offset by the same amount too, which is really bizarre. So, how the hell does it work? Okay. It's not solid. So we only want to insert that if it is solid. Is solid equals false. If any block in the current layer is not solid. Or or if y doesn't equal 0 and okay, now here's what we're gonna draw. We draw it if true. So we're going through a layer and we're saying if this block isn't solid, draw it. Don't draw it. Maybe it's like this. Why? Because you're in the block below. Oh my god, this math is just doing my head in. All I'm trying to do is check to see if the block below is solid. We're apparently stuck inside the ground. Entity, in here, go, rigid body, text. Nope, it's still generating it. Oh god. Alright, let's try that. And say, hey, you can only do it if it's on the bottom. I mean, it kind of works. I don't know to what extent that would be working, like in terms of basically it'll only do this if the bottom layer of a chunk is solid, which saves a lot but doesn't really save anything. If that makes sense. Now the chunk, okay. I can only remove blocks on like the inside of where a collider hits. So that's pretty funny. Oh right, because that's what it was doing. It was placing air one block in front. That's why I could place air inside. Well, I mean, it kind of works. Okay, I don't know how to optimize it. Without spending like lots of time like analyzing each direction. Because that's basically what I'd have to do. Is like what I've done there is I'm iterating through. I'm iterating through and working out like, is the XY plane And literally, like, it's is bottom XY plane solid because it only, like, I could probably make this even faster, really. I should probably stop printing this out. That would, for one, speed up really quickly. But, like, in theory, I could do this outside the loop because it literally just relies on chunk area, because we may as well just check that. Say it is solid. For Z, and then we just pop you out here, and we say you, and then we say you become is X 0 Y 0 solid, and then we say here, and then this is X0 Y0 as U32. I think that's one. I32. I32. Convert the Boolean so it starts at 1 if it's solid, otherwise it starts at 0. And then you don't have to do this because it's always going to be at 0. And then we work out why you're wrong. Well, okay. Direction down. We skip the entire layer if it is, so. Guess what I could do is maybe run an algorithm that checks to see, like on each slice, you know, on the X, on the Y, on the Z plane, if it's solid, and then inserts the corresponding mesh by checking, like, only if the next, like, if the layer below is also solid, then don't bother, but otherwise do it, because, see, that works, and it's probably significantly faster in terms of the fact that it doesn't need to check multiple times just to decide that the bottom layer needs it. Now to work this bit out. So it's going... Is that the positive direction? Oop, that crashed. Fun. Yeah, there's something wrong with the editor, so it crashes occasionally. I want to go... No. I just want to look at your transform. And I want to go as hello. Can we turn you back, please, to rigid body fixed? All right. So I need to go hello you. Yes. So that corner is too far. So if I walk forward right now, that's negative, positive, negative X, positive Z is too far. No, I've probably hit something, haven't I? That corner, that direction, that is negative X, positive Z. Negative X, positive Z, and they're probably half too far. Well, no, because you would be correct, which means that it's a whole block too far in the X. What's weird is it's positive Z. That's the thing I find the most bizarre about the whole thing, is that it's the positive Z direction. And then, like, if it was negative, I'd be like, okay, so it's going too far. Anyway, so to work out that chunk, it's not half length. It's probably like negative half length plus chunk size. There. Let's try that. Because I'm adding a half and a half again, and that's why it would be out by 1, is because we're saying a half and then a half. So I've added I'm adding negative half instead of half, which is the equivalent of subtracting 1. See? Math. Okay, so basically I just like needed to shift the whole thing just a little bit off like that. I do question why there is no face generator there at all. Interesting. Oh, I bumped into something. Oh, right, yeah. Navigate through the pillars. Okay. How to generalize that to more than just solid? Like more than just the bottom face. Like I want to do it on the side face as well, just again, so that when you're in here, it doesn't look as chaotic. So to generalize that, we would need to go, okay. So we're probably going to say like is, okay, let mute solid underscore plane. Solid Y. Planes. And equals an array of true by chunk. True by chunk size. Right. So it's a mismatched type as you says. Okay. True by chunk size. Okay. Yeah, more fake Minecraft. For y in 0 dot dot. I'm glad you really enjoy them. I'm finding them immensely stressful at the moment, but that's more just because shit's not working, and that's to how my brain is. It's like, I'd be having a lot of fun if it was working, but if it was, because it's not working, my brain just goes, okay. So it's not you that I want to set false, it's, solid XY plane, Y, as use size equals false. It's better to do a single cast. I'm not actually sure if the casting makes any difference. It probably gets compiled away into like 0 cost abstraction because there's a specific instruction I know that when you like load them into something. Alright. So then we're gonna go here. I'm gonna go you are equal to solid Y plane 0. Just so that, again, none of the code breaks, we are going to extract out this. So the idea is that this should propagate through. So we need to, again, go back to doing Y times. Okay. Minimal number of casts. Okay. So this goes through an entire plane and goes, hey, if any of these blocks aren't solid, set that not to solid. All right. Then in theory, we go here and we go, you're starting here, but what we need to do is go like match direction. And we need to go like, we'll to do this later. But what it's going to do is it's going to match the direction and it's going to continue if the plane is solid. So first off, I just want to like print line. No. So we're going to say something like if is x is solid. Okay. Well, we can really probably just be like solid y plane 0. Like so. And then the next time we used it, which is down here, this is solid y plane 0. Alright, so we're generalizing this away. And we're going, okay, we want to go and insert all the solid y planes that aren't immediately solid planes next to them. So, for y in solid y plane. No, we probably want 0 dot chunk size. Okay. So for each y in the chunk, we want to say extend. Okay, wait. We want to go if Okay, this probably needs to be abstracted away. Maybe. I've got to stop including so much crap. Right, so we go, hey, if you're 0, so then you would start at 1. And then we say if solid plane y equals, okay, no, we just check. If that's true, and then we just do all the exact same stuff as u. Wait, and not solid plane y minus 1. That's why I need to start at y0 so I don't have to worry about overflow. Yeah. As u size. Then just do all this fancy stuff. This should allow for non-zero y-planes. So, first off, we need to go u plus y as f32. Okay, so chunk. So you start at 1, you go through chunk size. And we say, if the current chunk that we're looking at is y plane, and the chunk below you is y plane, is so if your plane is solid and the chunk below you isn't solid, because the chunk below is solid, don't worry about it. Then we draw the triangle in, the plane in. This needs to be able to be generalized out, but it's getting very complicated. Okay, main run. So basically the way to tell if this is working is we're going to go here. All right, hello, you, yes. We're going to go rigid body, we're going to go fixed. We're going to go, if I fly over here, we have a flat plane here, we have a flat plane here. And then if I come over to this hole that I've been digging, and I go, yes, hello, please, place, well, something spattered an error, that was... Failed to gen chunk. Okay, that's just a general error. One. Why can I no longer... Weird. Anyway, if I come up like right in the middle here, it should place... Well, a monstrosity in the middle like that, but... let's extend it a little bit so that we can... Just, hello, please stop just placing more and more blocks. Did you draw a big plane below? It's kind of the problem I'm having at the moment. What is going on? I'm just trying to work out if it's placing it properly. Okay. Above you, yes. Look, big one. Right. Now, the issue is that it's still generating this one, which it shouldn't be. Because it's decided that this is solid, so this shouldn't be generating. So the way to do that is to go up. Okay. So up up needs to check down, which is going to get very confusing very quickly. Okay. So match direction. All the directions are going to do nothing for now. Okay, match the direction. Right, so if you are checking the direction up, you need to check, not if your plane's solid, because you wouldn't be being checked if your plane was solid, right? Current getter is solid. No, so it must be that block checking down that's generating the mesh, because the air doesn't generate meshes. So when it's going down, we need to check to see if the current plane is already 0. So y, solid y plane, y as u size equals 0. Is it? If continue, that should be all it takes. Is check down. And in theory, up should be the same. Check to see if the current plane is solid. Because when I spawn the up plane, it will also do the same thing. The only reason at the moment it's like it looks like there'd be a difference is that it's spawning down. But it's like we also check up, and it's because it's the plane itself that's getting the layer, which means that you up and down is both just checking to see if yourself is solid. So both of them can probably be generalized into the same, like, you know, if up, if down, check the same thing. So that means if I go down into one of these blocks that's nice and solid, and we place this, it should not generate the one on top. I don't see the one on top, which means if I come over here and I go, hello, yes, please, turn me into a dynamic again so that I can fall down. And I can go, hey, look, you're solid, and I can walk around you. You've got a wall going in all the directions, yeah, but you don't have one on top of you, but I still can't fall into you. So, as you can see, we now generate a plane. So this plane covers the entire base, and if we spawn a block, we spawn a plane. Okay. So, we also need to generalize this into we can take this, I'm going to go down here, and we're going to go, this one is chunk size -1. Do exactly the same thing, except I think we want to make all these negs into positives on the Y plane. So, I should also probably move all these constants to like the top. Just so that I'm not declaring the same constants absolutely everywhere. Okay. Yep. As you say. Also, none of this casting should have a problem because it's all constants, which means it should all be compile time optimized away. Which, I mean, admittedly does add to compile time, but we're talking fractional amounts. So, extend that, and you would be at this, but no, that should work because the well, no. This may need to actually stay negatives. I'm not sure because I think we end up doing. Well, let's leave them all negative because I think this is going to do the same thing where we're going to add chunk size to it, and if we don't leave them as negatives, we'll end up actually pushing it a whole block too far. So this checks it is solid -1 and spawns the top. So if this plane is solid, spawn the top, and then that means this spawns the bottom. Okay. Okay, so if 0 is solid, spawn the wait, do I have to do one above? I'm just trying to generalize things out again. So we spawn 0, and then we say, hey, if chunk size -1 is solid, spawn that at the top. So this is the equivalent of checking one above you looking below, which I think means because we check chunk size and then chunk size -1, this is the equivalent of doing chunk size +1. This one is the same as doing chunk size +1. Well, not quite. Right, yeah, it is, because we then spawn it above, which is this is going to spawn the layer below, and this will spawn the layer above. So that should mean that each chunk does its slicey slice, and then each plane spawns its plane in, And then again, each plane is at plus y, whereas you should be at plus chunk size. Yep. And then your values would be exactly the same because we're just plus oneing. And y never actually hits that value. Okay. So then we go through here and we go, you start at plus 1, which I don't think we need to do that because that's like a lookup and a convert. So we should probably start at 0 and just say if direction is down, if y is solid, continue. And then we got to say if direction is up, do the same, because in theory, up and down are going to do the same thing. Like if the plane is solid, then we've already spawned your top plane and we've already spawned your bottom plane if the current plane is solid. So that should hopefully not crash for one thing, but hopefully mean that it won't spawn those like slices out if the plane is solid. Right. Well, we're kind of stuck in a wall here, so we're going to go here, and we're going to go fixed. Okay. So, well, we can have a little squiz in here and go, yes, you're spawning a correct plane. So you've got a plane on top. Do you have a plane below? Doesn't look like it. See, there's no plane below. You have a plane. Okay, so there's the bottom. So you, which is plane 0, and then so plane 1. Plane 1, well, that block's not there. So you spawn this one, and you spawn regardless. So I think you should spawn one lower down. Right. That's really bizarre. We need to move into like chunks that are completely underground so I don't get interference from other chunks, and we need to do it like right in the middle of a chunk. So again, we don't get interference. So you have a plane on top, but you don't have a plane below. That line also looks really thick, but we'll ignore that for now. So you're not spawning a top, but you're also not spawning a bottom. Yeah. Like, you have a left or right, but you have no bottom. Okay. So why is there no plane below you? That's got to be something in here. When we, so if this plane's solid, spawn one below. Spawn the bottom layer. If this one's solid, spawn the top layer. So you should have a top one. The issue is I have no way of knowing the top one is the top one or whether the top one's... I guess what we could do is come over to this corner, go down and go... Okay. That's probably got something to do with an overflow. Add chunk meshes, multi-thread. Is it... So that's definitely the crash point. Okay, so... Run, single-threaded, run, okay, so... World mod. No. Event handler app. Pool. Panicked. Chunk 2 world ID. Expected chunk to be in world. Right. Didn't really consider that. That's a crash I'm going to ignore because theoretically that crash shouldn't be possible. It's only because I'm debugging shit and I've technically set my render distance to significantly below. Like, because I've set the render distance to less than 1. I haven't got the escape menu turned on. It's possible to reach the edge of a chunk and actually touch the edge of a chunk. And that's what that crash appears to be. Not 100%, but best guess, that chunk is I tried to update a chunk that's not actually existing. And therefore, we have an issue. Okay, so we need to come up. We need to go, we were removing like this block. No. Why didn't that work? I was coming over here and I'm saying, hello, please remove this block. Okay. So that means that you've got that layer and you've got that bottom layer. So does it mean you're not spawning your top layer? What we're looking for right now is a diagonal line from one of these corners. Right, no, you need to actually generate yours. That's why there's no diagonal line. All right, so you've got on top of that block, but you have the bottom of this block. And does this block have it? Oh, it's gone. It's really hard to tell. Okay. You have 2, and I see the bug. That's connecting to there. So your Y should be -1/2, I guess. So that's not this one. That must be this one. So we had chunks, so it should be, I guess, -1. Wait, no, it's. I never backed this out then. -1/2. So that would explain why everything else worked. It's not U-1. That was correct. It was U-. Okay, so now when I run this bad boy, it should work that if I do that same thing again, we end up with the top layer and the bottom layer. All right. What do we want? First off, we need to set our render distance up so that we don't crash. Okay, and then we're gonna go here. We're gonna say here. Yeah, you're fixed. Thank you. All right. So, how did we end up all the way down here? Probably because we fell through the ground. Okay. I love all the dots moving around. It really shows off floating point errors. So we want to come in and we want to do the same thing. We're going to go all the way up and go, okay. So you as a platform. Okay. So right about there. Okay. Not entirely sure why that's not rendering weirdly. That's pretty bizarrely rendering. Okay. Anyway, so then we come into this one and we go place a block here. So you have the top of this one, but you don't have the bottom. You have the bottom here, and then up here you should have, there's 2. So we're rendering the top of this one, which is this block down here. I've considered streaming on Twitch. Like, I used to do it years ago when I was younger. But I don't like the, like, not predatory practice, but like I don't want to support, what are they called? Amazon and like, I don't like their business practices. And the fact that they screw over their creators with like literally no thing. It probably wouldn't make a difference to me because I'm a small creator, but it's that moral thing of like, if all the small creators agreed not to stream on Twitch, then Twitch would get better. But since most people go, oh, well, there's no point streaming anywhere but Twitch. Twitch doesn't have to compete. They can literally just continue being a monopoly and be dicks. So it becomes that. A good example is Netflix stopped password sharing. And everyone was like, I'm going to cancel my subscription. And then Netflix reports that they've got millions of more subscribers because all the people that went and made... So now Disney Plus is going, oh, we're going to crack down on password sharing as well. It's like, if everyone actually cancelled their subscription like they said they were, then immediately Netflix would have pulled back. Yeah, that's probably also partly to do with my internet connection, because it's saying my current streaming bitrate isn't high enough. It recommends about twice the bitrate, so it's probably also partly that. I'm sorry about that. Hopefully, as I could probably turn the latency up. Maybe I might have to do it for next stream. I can't change it while it's running to like normal latency. I've got it on low latency, which means the encoding will be worse, but you won't have to wait as long for me to respond to messages. Anyway, so it's definitely spawning the top. It's definitely spawning the bottom. We need to just work out how to spawn the actual bottom. And the issue with that is, how do we spawn the... I guess... we spawn the bottom if the one below. Okay. So, if zero solid, spawn the bottom. If one solid, spawn the top. For y. If y is solid and -1 isn't, and then spawn that one. And then I guess we go... and... I need to spawn the top. So we need to say y is less than chunk size -1. Okay, so if y is solid and y is less than chunk size -1, can I do this? Well, it's short-circuiting. Short-circuiting means that this should additive, like I shouldn't need to wrap this in parentheses. What is y? Y is a u size. Okay, so it's u size. So chunk size -1 and y +1 is not and not y +1, and then we need to take this and we need to say this is apparently fucking Starlink decided now's the time to change satellites. So that's another fun thing about streaming with Starlink, is that every now and then it's just like, yeah, goodbye, internet. Oh, hello, internet. And it's like, oh, okay. Anyway, if we now... This is the first time I've parked the player directly in front of the camera. No, we want this one. Okay. So if I go out into here and I place a random block, like here, it should have a big on top and a big on bottom. Look at that. We have two planes, and then it doesn't spawn the top and bottom, but it acts as if it has a top and bottom. So for basically exactly the same, you're trying to put it with my finger. For the two triangles that we would have used to generate this face and this face, we've generated an entire plane. Because why not? You know, like, it's the same compute. I don't know on a physics engine level if it's the same compute, but on a graphical level it would be. And since we know this one's solid, it won't do the rest. And we don't have to worry about there being two like overlapping triangles, because this one will only spawn up if there's a gap here, and this one will only spawn down if there's a gap here, which means it's not actually possible for two, like an up and a down, to spawn on top of each other, because they only spawn if there's gaps. Okay, so the question is, do we commit? So, because that's run like frame to frame optimization is what I would call. So technically, the chunk generation takes way longer. I think I can also set you to 0. Wait, no, you're 1 because you're just spawning the planes. The chunk to chunk generation is like, or the time it takes to generate the mesh is slower, but each time it takes, like, when it comes to running physics collisions and rendering, it's faster. So I don't know, it's a trade-off, I guess. Okay, so what we need to do is generalize this out. So let's say X and Z. So we assume that all planes are solid, and then we run through X, Y, Z, and then we say, if this block is solid, Y plane is solid. Wait, what? Oh, so I can literally just run through that loop once and say X plane X Z size equals false, and solid Y plane Z plane Z. Well, first off, why not go? Oh, because I have to multiply by chunk area and chunk size. Well, actually, no. It probably would be better to go U size, because I'm doing casting. So if I cast them all as U size, I can cast the consts, which should in theory not have any compile overhead, because the const will literally just be converted once. So since this is a constant multiplier and this is a constant multiplier, that shouldn't have any difference. And then we can just say Z equals false. And since we basically override, like so basically we are saying, assume the plane is, assume every single plane is solid, you know, X, Y, Z. Then iterate through every block, and if the block's not solid, set the corresponding planes where that block is to not being solid. This means that with a single loop through, we can pick out every single plane that's not solid, and then the rest of the planes we assume are solid. So this would be the, okay, so then we go, this is the Y plane. And then we go here, we go, this is the X plane. And they're all negative, which doesn't feel quite right. It's probably because we're adding chunk size. I'm pretty sure these need to go back to being positive. The ones we added chunk size need to go back to being positive. Because that's what it was. Is because we're adding chunk size, they became, so negative, negative, negative. Alright, let's just quickly go back to block and go, it's back. Okay. Negative. No. Down. Down. Negative, negative, negative. Positive, negative, negative. Okay, so this is, so we're going to need to go, this is X. So X is left and right. So if we just take left, which apparently left is also negative, negative, negative. So, wait, is left and down the same? No, so they are actually different. We probably want to take, left here, We go solid X, and we go, yes, hello. So we give you left, and then we go, all the positive ones need to be plus chunk size as F32, like so. I'm hoping this generalizes out. Three of the corners expanding, one command. Okay, yeah. So that makes sense that we would expand 3 of the corners. And then we need to expand them by -1/2 because... So basically they all expand by -1/2. I'm just only... I kept them as not -1/2 so that I knew which ones to extend. And then we should be able to do that. And so this should mean that if the x-plane is 0, and then we want to do the same thing for the z-plane. Where's my z-plane? Block. Which would be... So we went down, we went left, which means we want to go back. I believe. Maybe we want to go front. Down. Left. Probably front, because I think we go front to back. -1/2. Okay, let's just go with front. We can always just tweak the values until they line up. Okay, so if x-plane solid, and then if z-plane solid, and then we want to go hello z-plane. I would like to paste in this information. Okay. Like so, and then these two go away. So we have our half lengths like so, and we're going to go all these half lengths. We want to add chunk size to half length. Okay. So plus chunk size plus chunk size. Okay, apparently I've double spaced it. Okay, so there should be one that goes 2. Okay, paste there. Okay. One, 2, 3, and 4. Okay, so for those that weren't following along when I said there should be 4 of them, is basically the picture the 4 corners again. I'll draw my little diagram. I love my little diagram. So dot, dot. It's one of the few times where I don't like that my thing has those glyphs. Anyway, so we have our square. And to expand it, what we're doing is we're taking one corner and moving it so many spaces that way. And then we're taking another corner, this corner, we're moving it that many spaces that way and that many spaces that way. So it's just moved down and across. And this one just moves down. So as you can see, this one hasn't moved. This is moved by 1 in the one axis. This is moved by 1 in another axis. And this is moved by 2, 1 in each axis, which if you look at this, you'll see +1, +1 in, and +1 in a different axis. And so this is axis 1, 2, and 3. So we add 1 to 3, add 1 to 1, add 1 and to 3. So that's our this corner, 1 and 3. So add 1 in 1, add 1 in 3, add 1 in 1 and in 3, and then this one just adds 1 in 1, which is this one, and then this one doesn't get changed at all, which is this one. Theoretically. So that expands our z, and we say if it's z-plane, and we do exactly the same thing, and we go... This would be slightly more complicated if we were messing with visible meshes, because you have to make sure that the orientation is correct. They need to wind counterclockwise. Otherwise, they'll have the wrong face plane and they won't be visible. Or like you'll be looking at the back of the mesh and not the front of the mesh. So depending on how your shader is set up, that won't be visible. Okay, so first things first, have a look. Does it have the cross line? It does not appear to have a cross line, which is somewhat depressing because that makes me feel like it's not working. And I was looking forward to this working first try. But no, don't hide the player. Oh, just I've done this too much. All right, so let's go all the way down here and go hello you. If I go into a completely ungenerated chunk, let's just first off we should probably tweak our view distance back up just a tad. Okay, you. Why can I not? Oh, because we need to get air. Okay. So you're generating that way. Are you generating across? I don't see one. Have I done something stupid? I see one that way. I see a whole bunch of funny lines, which, you know, for example, this one, which doesn't seem to go to a chunk boundary. We've also got a cross back and forth, which means that one of these is also not working properly. One of these is incremented in the y-axis, like what? Alright. So, x-plane. It also should only do it on one side. We're only doing it on the positive x-plane. So what's going on? We have negative, 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 negative. Okay. And then, I'm pretty sure that's just how it goes. And then you just place it in. Okay. So, which one do you think is wrong? Well, one of you needs to increment in the... What axis is that? Yes, hello, direction. What axis is forward right now? Negative Z. So one of you needs... Oh, no, it's moving in two axes. That way. Which one's growing faster? Negative Z. Right, so one of you needs to move slightly in the negative Z direction, but you're also just the wrong face entirely, because you seem to be drawing... Like, there's no missing block, and you draw from one corner to another corner. Alright, which of you moves in the Y? It's probably not that one, because none of them move in the Y. There it is. Wait a second. You still have half lengths. You shouldn't have half lengths. There should only be 4 of them. So we need to go back to our block and make sure we grab the right one. So we must have grabbed forward, which has how many half lengths? 1, 2, 3. It's too many. So if we said back, how many does back have? 1, 2, 3, 4. So it's back, not front, because front just has more. Okay, so we're going to paste this here. We're going to do the same thing. We're going to go, I need... Which would also explain why it's extending in the wrong direction, is because I'm using the fact that I know that these are the correct ones to increment in order to increment it. Okay, there's another half length, half length, half length. Okay, and then we want to take all of our half lengths and turn them into negative half lengths. Again, because they're only marking which ones needed incrementing. All right, let's try that now. Because the other thing I can do is turn off the generation of the corresponding faces, like the planes, down in the other bit. But I always want to make sure that they're working properly before I go fucking around doing that. Right, this is doing my head in so fucking much. I'm going to literally fix it right now. So player controller, FN, no clip. This takes in a mute query for something with player. And we need a rigid body. And then we need to say, okay, players, and then we say, we need input, which is a res input keycode, and then we say, if input dot just pressed, keycode F12, for mute RB in player. And then we say RB dot match RB dynamic. So we can say that next equal RB. So you're going to be rigid. Fixed. I guess it's more like everything else turns into dynamic. Okay, and then RB, dereference RB equals next. Dereference. Okay. Dot, fine. No clip. Okay. Thank you. And it annoyed me enough that I've implemented no clipping. Now, admittedly, no clipping should probably be done with a component, just so that I can do things like when I swap to a player controller and whatnot. I can do fancy things. Anyway, so that face has nothing. That face has a beautiful line through it, and that face has a beautiful line through it. And then this face does, but that's because this one has one. And then that one does, and that one does, and then here. Okay, so we go back to our collider. And we go, okay, so this is if C, and then we go here and we go, the difference between you and the other one is literally just what we do. We just offset you by that. Okay, so in theory, we can go copy these two, please. This is where I'm copying and pasting a hell of a lot of code. I should probably move this to like inline systems or something. Okay. So there's our this, and then we want this to be chunk size -1 as usize. How do I keep not collecting the whole thing? And then finally, we're going to come down here and we want to go, yes. So this is X, which is this plane. So plus chunk size as F32. And then we want to go down here and go here and go the Z plane. So we want to move the Z axis plus chunk size as F32. Okay. And then we want to go main and we want to go run. And this should spawn the corresponding 2 faces? 4 faces. 2 faces. We already had the other 2. So if we were to come in here, go boop, we should have line, 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 line. Right. And then we see a line, line. So next is to, I guess, do the X, do the Y. Now, again, I think I can compromise this into a single loop. So we've already done that, So we can probably do something like this as I, and then theoretically, because we check the plane and the plane's kind of independent of, so we could do this, and we want to go up here. I'm going to go, okay. So let's add some comments for people wanting to read this. If below is not solid, if above is not solid, if left is not solid, so this should be the X, do all the same stuff. Right, we need no, this is it. We need X's code. X. Z. Then we just want to paste this here. Oh, God, I've got more copies of the same goddamn crap. So there's a Z, but then we want to go something like take that away. So then they should run the same logic, and then it's not its position, it's X plus I. Okay, so check solid, check left not solid, and then this one will be if right not solid, which is I and I and I, but these need to be X planes. Then this would be exactly the same. But again, we're going to copy this section and paste it here. Don't put an S there. We'll get rid of that. I'm going to come over here. I'm going to go, it's not you, it's you. Okay. So if right not solid. Okay, and this is if back not solid. So again, we need to go copy the Z. We need to copy like the Z's logic. So if back not solid, which is just this section here. I just want to quickly do it here before I go losing my copy paste. All right, so we go U as Z, U as Z. So if Z's not solid, we do that logic, and then we go, we need to increment Z by the correct amount. And then we need to go down here and say, these are also Z planes. And then we do the same thing by getting that off. And then we say if front not solid. Fr. I can't spell. I'm not even going to bother at the moment. And then we're going to go Z. Okay. So I plus 1. So... Okay. So if the Z-plane and the Z-plane's plus 1 is not solid, and then your minus 1, okay. 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 Here's one more piece of tidying up that I want to do in here, and that's these have this stuff which is just like compile time garbage that's not needed. Literally makes like no difference, but anyway, so we have our X, our Y, and our Z planes are all spawned like little crazy blobs, and then we go here and go if up, down, and then we check if plane Y, and then left, and then we go hello left and right and front and back, and then you say left solid. So this would be X and this is going to be Z. Continue, and so that means that we don't match if and I guess one thing I could do is go also check to see if all of them and then break, but it might, the compiler might even optimize that into it. I'm not actually sure. I don't know how smart the compiler is, but in theory, because I break on any of the planes being solid, if all 3 planes are solid, you can just break the loop rather than continuing the loop because you already know. Okay. So you have a lot of lines, but you also are a corner block. So distance. Oh god, it's taking forever. See, like, you look pretty cluttered, but the reason you're pretty cluttered is because basically every single axis has at least one block that's exposed. Whereas this one has probably a single block that's exposed. And then as soon as you get over here, it's like there's no blocks exposed. So if you see a line through it, it probably means that at least one block is exposed. I guess the question is look from the outside and go, do you see any blocks that are not working? Nope. And then it's not really possible. Like if I find a chunk boundary, the only way to really test is to like clear out an entire face of a chunk and be like, make you completely solid. So maybe we'll just do that quickly. Wow, you fall really slowly. Yes, hello. No, I want to set it to 1, please. Help, I got stuck in the ground. Okay, I don't know what's going on with that one. My guess is that an old chunk probably generated in, because, well, theoretically the task should be cancelled if you request to generate a second chunk. Like if you request to generate a chunk again, it should cancel the task, simply because the yeah, I don't know. I don't know why my character is bouncing like this. I'm just gonna have a quick squeeze and be like, Bevy console, are you updated? Please. Last month, updated to Bevy 11. Okay. Sweet. So. I keep searching stuff on Google and seeing my own videos. It's very disconcerting. Do you have a crates link? No, maybe. Yes, hello. I'm not seeing it. Bevy mod debug console? No. We'll just copy the git. What's the harm? Right, so exit. We're gonna go to our tunnel. I might just quickly go to here, go wherever it was that I did the thing. I think I'm done with this, so I can discard this change because I don't want to turn off that for everyone. Player controller. I added this. So we'll do this quickly and go added no clip with F12. Okay, cool. Okay. We want to discard this because this was for debugging purposes. And discard this because this was also for debugging purposes. And we want to say fixed made mesh optimization. Okay, made mesh optimization. Push. Okay, for anyone following along, they want to go to the Git, they can now get that. Anyway, what we want is we want to say Bevy underscore con sol equals Git. Alright, so the Bevy console, for those that don't know, is an amazing plugin that lets you basically have a console that lets you do things. Really fun things, like custom commands that I can literally type to do things. So we're going to be like app.add plugins. Okay, we probably want to go world. Really, the world should have its own plugin. Why? Okay, I do have a world plugin. Never mind. Mod. World commands. That's not how you make a module. That's how you make a module. Please. Okay. It's just building a bunch of stuff. I'm going to insert an ad and go to the toilet quickly while this all compiles. So I will see you all in like a few minutes. Alright, funnily enough, when I went to play the ad, it told me that it was going to play an ad in 30 seconds, so didn't really insert much of an ad. Or, like, I did, but like, yeah, it makes sense. Okay, so, I gotta remember how to use this. So we're gonna be like, use Bevy console. Do you have a prelude? No. Command. Maybe. Why do you not have a prelude? Add console command, console command. Okay. Just gonna go to here, go to here. Yes. Hello. How did you add a command? Drive parse console command string. Oh, do we have to use clap? Don't make me use clap. Why do you not re-export shit? Okay, so we have our world console here, and then we're going to go mod here, and we're going to go parse. Yes, it's because it's clap apparently. Does Bevy console give me access to it, please? Use Bevy console. Parse? No. Nope. Okay, we need to use clap then. God damn it. Use. No. Clap. Pretty sure clap's just a parsing algorithm, but it's just, it means it's going to have to recompile a bunch of stuff that I was hoping not to have to do. Okay, so we don't want this bit. We want to go up here, we're going to go, so we're going to have setup, which is going to take in an app, which is going to be a mute app. Okay, and then we just say app.add console command. Example command, So add console command. System, so we need to, T and params and T and help and look. Okay. So we want to go clear. Name is clear. Chunk, which is going to be a chunk ID. Yes. Are you going to tell me that chunk ID can't be? No? Okay. Console command is a list of the commands, and then it would be example command. Clear. This would also be clear. And finally, clear. Right. Just make sure nobody's leaving messages. I always like change to a window and then I'll come back and like that's the only time people write messages. Clear. Okay. And so you expect to find chunk. Okay. Well, that's somewhat working. Expected for but this trait does not set it for value. Okay, I feel like I need to implement the clap parse on this or something. Parse. No? No, is it? Enums. Okay. Well, I mean, the easy way to do that would be X F32, no, or I32, Y I32, and Z is an I32. There we go. Then we just say here and we go X, Y, Z. like that, and that should fix it, because you should be able to parse that easily. Okay, we will need that, but we also going to need a map. So res map, just a res map. Okay, so handle the command. Okay, we want to say let mute map equals map dot 0 dot read. No, right. We want right axis, and then we want to say we should be able to unwrap that. Dot unwrap. Okay, and then we want to go map dot set block. I remember how set block works. And we can probably just set this as its own thing. Clear chunk. And this will take immutable self. Self and a chunk ID. And then get chunk mute. And then we say chunk dot blocks equals, okay, weird. Alright, so set all the blocks to air, and then it's can mesh.insert, and then for n in chunk id dot neighbors self dot can mesh dot insert chunk id n. Okay. Okay. So then we go to world here, and we just say, can you clear chunk, and we go chunk ID new XYZ. All right. We want to clear command. All right. So you call clear command, and then okay, and then we want to go here. I'm going to go when we do this. We want to go setup. We want to go world commands setup app. Okay. So we want to call setup on this, and this will be the only part that's exposed. So you need to be pub. Okay. And then we want to come. We want to include the console plugin, which we've already done, and from there we should be good to go. Okay, it's not too much more to compile. And so the console plugin should let us press, I think it's tilde to open, and then we should be able to type in clear 000, and it should clear chunk 000. The idea, and then obviously specify the neighboring chunks to be regenerated. This could cause some issues, but it probably shouldn't. I think I've made it robust enough. The issue is that I've said regenerate all your neighbors, which means that theoretically you could say clear this chunk that doesn't have any neighbors because it itself does not exist. Okay, so the other thing is I should probably get or insert empty. So if you say clear a chunk that hasn't been generated yet, it should generate an empty chunk. Right, so clear chunk. Okay, get. Okay, else self dot chunks dot clear. No, don't insert chunk ID chunk chunk ID none, and blocks is I guess it's just .default from there, isn't it? No? Do we not implement default? Fuck off. Blocks, and then blocks is just... Cool, cool, and then return. So if you call clear on a chunk that doesn't exist, it will spawn the chunk in with nothing in it. So the idea behind this basically being that I should be able to come over here and be all like, please, no, tilde, clear, zero, zero, okay. Found unexpected argument 0. Okay, you're annoying me because you tilde. Why did it say unexpected argument? Okay. X, Y, Z. No. Invalid X invalid digit found for string from string. Okay, help. Help. Clear. Dash help. Usage clear. Okay. Clear. Unexpected argument 0. Some message. Usage clear XY 0. Unexpected argument. Right, so we probably shouldn't. I think we've got a conflicting name. So I think what we want is we're going to go here and be like clear chunk. Okay. Boing. Okay, so it's definitely picked up on it. So 0, 0, 0. Hey, it didn't do anything, which is probably a plus, because if it's not doing anything, means that, well, there's no missing chunk, so wait, isn't there? That's interesting. So the fact that it's drawing the sides like that, right? But it's still rendering, which is even more bizarre. Because surely if I go, no, we're going to clear chunk. Can you fuck off? Okay, so see how it's removing but it's leaving the mesh. That's interesting because that implies, for one thing, that I've got a bug in here. The gen mesh returns an optional mesh, which apparently isn't an optional mesh. It should just be always return a mesh, please. Yeah. You always return a mesh, but instead of returning none, you're just going to what have I done? No. You always return a mesh. But, you know, if you is empty, just return an empty mesh. Don't bother setting everything up. So we'll have a slight allocation issue. Yeah, check. So what's happening here is basically I return an option to whether there was any blocks at all to even generate. And the issue is if it's getting no mesh, it mesh, which is just going to be data.main mesh. What do you mean? Okay, that was carry error. So basically, it was not resetting the mesh because the mesh already existed. So, well, no, because there was no blocks in the mesh, it didn't override the currently existing mesh, which means that it, even though it regenerated, it didn't regenerate the non-existent mesh. And water and colliders are regenerated regardless. So it's just to do with how I'm doing it. So if I now go console and go clear chunk 0, 0, 0, clear chunk 1, 0, 0, clear chunk 2, 0, 0, and clear chunk 3, 0, 0. Help. Tilde, escape, E. Hey, okay. So, question. I need this block not to be solid is what I need. Yeah, no? You don't seem to have a collider on you is what's concerning me. Right. Yeah, it's working. So, as you can see, from this. So, this face is completely solid. So, it's drawn a completely solid in. The other lines you see is there's a block here and you know, in inward. So, it's got two planes going, you know, this way, and they're going in through on the z-axis. And these two here are going through on the x-plane. And then there'll be two on that side going through on the, I guess that's the Z. So these are going through on the Y plane, or whatever. No, I guess this is on the Y plane, this is on the X or Z plane, and this will be an X or Z plane that way. And where these 6 flat platforms intersect, that is the air block. And the idea being that this face here is because this is air. Or actually it's because this is the edge of a chunk. But if we go back in here and go, there it is, and go down here, fire, and then come back out here, it shouldn't have drawn any additional lines. See, so it's got wider and it's got taller, but see how it doesn't have a line in between because these planes only appear if they can go all the way across, which they can't because these two blocks are next to each other, which means it couldn't draw a plane between them. But in theory, if I come down here and I was like, punch a hole here, move over a little bit, punch a hole here, they should, as you can see, if I can get it somewhere where the escape menu is not going to get in the way. Escape menu is always in the goddamn way. Okay, as you can see, here's one, here's the other. They've got a space between them. It works. We've optimized the meshes, the collision meshes, to a point that we can completely clear like huge, you know, the only places that their meshes look really complicated is where, you know, we have lots of blocks. Another thing I guess I could do in order to, again, cut down on that noise is, but it would actually slightly de-optimize the meshes, but it would just make them look cleaner when you're inside the mesh like this. So as you can see, all these ones is make these not tunnel under, because that's why this is so noisy, is because these tunnel. If I instead only continued while the block above was air, and didn't tunnel under, I could probably do that. It would mean that like these don't extend all the way back, and you would end up with a much cleaner looking underneath. But I'm pretty sure that's technically more computationally expensive, because you would actually end up with less tunneling, resulting in more meshes. Because like if you had a block, say here, am I hitting my own collider? Oh, okay. Please. You can only hit static. So maybe I should make myself kinematic. Yeah, that would be better. So when we go player controller, don't go to fixed, go to kinematic. Okay. Untick all these. Where is it? It's this one. Changed to... this one. Alright, so basically, because in no clip mode I'm static and I'm casting a ray until I hit something static, I was hitting my own back of my own head, so that shouldn't happen anymore. Anyway, back to demonstration. So at the moment, this is all one mesh from here all the fucking stuck inside, all the way to here, like, you know, until the edge of the chunk is all a single mesh. But if I like that, so currently, with the way I have it set up, this is still one mesh, because it's going from here, it's checking each block, and it doesn't care if the block above it is solid or not, this block. It just ignores it and just keeps going. So this ends up being one or two triangles to like until the edge of the chunk. But let's just say this is the edge of the chunk. So from there to there is two triangles. What I could do is make it go from there to here is two triangles, and then from here to here is two triangles. This would cut down on all these triangles that are extending to the edge of a chunk, and would, in theory, cut down on, you know, like all this noise in here, because these wouldn't need to extend. Another thing I could do, I'm not going to, because again, it needs the chunks to be able to talk, because this is a good example of where I'm going, like, you could make these chunks that are completely solid not have their own collider, like they just don't have a collider. The issue with that is chunks like this, where you've completely tunneled out a chunk. So technically this chunk is completely solid and therefore has a collider. Has a box collider. So fucking weird. But you can actually collide with it, because I'm going like, well, there's no way you can collide with this because everything around it is solid. But it's only the case while the blocks are completely underground, but it is possible to have a block not completely underground but be completely solid. So fun. I think I'm gonna just expand some more commands, and then I might call the stream done. So what else do we want? So we probably want something like an enum command, and then we're going to go derive clap. What was it? It was value enum. Value enum generates a value enum implementation. Okay, so can we say like? Apparently, it needs to drive clone. A little bit clone and copy because it, you know. So I'm assuming this will work. We can say something like clear gen fill. Okay. And can we say like fill takes in a block type? Is that something that you can do? Are you going to complain that block type? Yeah, it only supports unit variants. Okay. So. I wish I could give it optional commands. So. Alright, we'll just leave clear and regen. Right, so and then we want to go, this isn't called chunk, this is a chunk command, and then basically you will say chunk, and then you'll specify a action, which will be a command, which maybe I should just rename to actions. Okay, clear, regen. Right. Then we need to say action. So we'll have our action here, and we're going to go, okay, so you can clear or you can regen, and then this is going to go, hey, match action. On a clear, call map clear. On a regen, I guess call map.clear. No, XYZ. And then we want to go map.genChunk. You return none if the chunk's already generated. Okay. So maybe we should say something like regen chunk. Regen chunk, which will take in an option to self, and you'll ignore this and you'll return nothing. You'll just do that, you'll regen this, and then you'll say let chunk equal that, and then you'll say self dot chunks dot insert chunk, and this chunk here, and we're going to say ID. Alright. Cannot borrow self as okay. Immutable self. Alrighty. This needs to be public. Regen chunk. So regen chunk's going to be slightly slow. Mostly just because regen chunk is not going to be running, you know, asynchronously. That makes sense. Like, yeah, it currently, like, the generate chunk is called asynchronously in the sense that, like, it will run in the background, whereas now generate chunk is not going to run asynchronously, so you won't be able to generate a chunk. Surely gen chunk should be async. Chunk. We can probably make this return a future, because basically what gen chunk will lock up while it waits. That could be another reason it's so slow. I really need to go through the like parallelization code and make it actually parallelize properly. The issue is that I don't know how to debug parallelization stuff. Like, I've had a lot of times where it's obviously stuck, something's in a loop, but because Bevy is waiting for a task to be done. The game runs fine. It's just I know that it's stuck because it never loads. And I don't know how to like see what tasks are still running and things like that to work out where it's stuck. Contains chunk is never used. Anyway, so with that, we should be able to now... where was our world command? So we can now specify clear. So we can say chunk clear. So we can play, and we can be like, okay. So if I was to go something like jump, 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 jump. Okay, we want to go tilde chunk clear 0 30 0. Okay. Tilde. Oh. Well, I don't know what I did to my menu. Okay, there we go. Chunk clear 2. No, tilde E. Escape. There we go. So this got cleared away. Interesting. I'm just looking at these crossed lines. It makes me feel like it's generating chunks, funnily. Anyway, so then we want to go tilde up and we're going to clear 1. So that clears that out, and now we have a nice little hole in the ground, right? But what we can now do is go, yes, please, bring that back though. Gen. Oh, it crashed. Why did it crash? Blocked on, future, blocked on. Future update, blocked on. Okay. Schedule update, create thrust update, event handle, panic. Chunk to be in world. Get entity. Okay, so our chunk commands here. Right. Clear chunk. So it's probably not regen chunk, because what's regen chunk doing? It's generating a chunk with the given ID and inserting the chunk. It's got to be, because clearing the chunk didn't do shit. Huh. I don't actually know why that didn't work. Because, like, theoretically, when I cleared the chunk, it shouldn't have despawned the entity. That's probably underground. I see a faint clearing. Interesting. So maybe it's because it's higher than that. There should be a big hole in the ground somewhere. Okay. You complaining? No? We would be outputting something if it was complaining. Well, 5's not existent. Fine. Oh, it's over there. Just like really low down. Oh, because it starts at 0, yeah. So why can't I regen? It crashes. So it's definitely something to do with how it regens. I'm very confused because regen doesn't override we call generate chunk, but we don't set the chunk's ID. And because we clear, well, we call clear first, but clear doesn't remove the chunk, so we insert a chunk. Okay. So you need to be mutable, and then we need to let. Okay. We're gonna be like let old equal old equal chunk self dot chunks dot get ID. So what we do is we get the old one, else return. So you can't regenerate a chunk if it's not actually been generated in the first place, which is reasonable. And then let entity equal old dot entity. Let sum old entity equal entity. Else return. You can't generate a chunk that isn't current. You can't regenerate a chunk that's not currently loaded. There's no real reason you couldn't. It's just that I don't want to. Chunk dot. We'll just entity. Okay, so wait. We can say old.entity. Okay, chunk.entity equals old.entity, and then we can drop that, and then we can insert a new chunk. That should fix everything, and then I'm going to call that a successful stream. Okay, tilde. We go chunk clear 0 to 0. I don't see it, so it's probably higher up because well, maybe it's lower down. Can't imagine the chunk's all the way down here though. Weird. Oh, there it is. Alright. So then we should try regenerating. No, we want one. I'm gonna go regen. Okay. Tilde. It didn't crash. Hey, it's back. Wow, it's back. Cool. All right. Well, thank you for checking out the stream. I think that, you know, it was pretty successful. There's now commands to clear and respawn chunks. I might have to look into how to make it so that I can specify like a fill with something, and maybe like a fill specific area sort of thing. Where you can, instead of specifying a chunk to clear, you can be like clear X to Y, like world edit commands. Yeah, so thanks for checking out the stream. Again, the Discord and GitHub are linked in the description of the stream, hopefully, if I did things correctly. And I will see you in the next one. And there's a video coming out tonight on how to use Bevy Rapier in your games. So I will hopefully see you all in that video too. Okay.